The 30 is definitely between 20 and 30, because up to here you've only got 20. So you need to take 10 of these. So the other way of doing it, so this doesn't actually answer, that's what B said is, this doesn't answer the question that this asked, but I'm fairly sure the question, if I'm asking it, it says use the ogive or otherwise, or it says you calculate the median. Just says calculate the median, so you could do what I'm going to do here, or you could do the ogive. So this would be like a B dash, a slightly different question. So the answer would be something like this. So you've only got 20 less than 20, but you've got 36 less than 30, so that's too many. So your starting value would be 20. Here. But you're going to need 10 of these. It's actually a little bit easier looking at the thing here. So if you look at the first, you've got 20 in the first, and then 20 to 30, if you add them all up, that's 36, but that's too many.
Because it's more than the median.
It's more than you need. You just need 10 out of those 16. So you do, I'll take 10 out of the 16 times the distance from 20 to 30, which is 10. And then that is 26.25.
That's what the median really is.
Well,
Is that Joe on
There's-
your
there's
graphic
pros
guess,
and
or is
cons.
it actually calculated?
no, there's pros and cons, so it's not too, so theoretically, if you could, the drawing one is better if you said a computer to draw the picture for you. So this has got the problems with drawing the graph. Theoretically, this isn't very good, but it has no, it's kind of, it's an exact in a way, but it's not. It's assuming the data is equally spread out on each of them, but actually, the data isn't equally spread out on each of them.
We're going to be drawing the graph anyway, so...
Well, you might be drawing maybe just a histogram. So if I were you, I'd just prepare for the different eventualities and take whatever is coming. Like you're going to be, definitely it'll be draw an ogive, or the median will come up one way or another. So you could decide you're going to do this, but it could be a hell of an awful lot of extra work, all this, when you could just get away with this.
Can you go through that alternative once more? And so the 20.
Well, yeah.
Why did you say 10 of the 16?
Because if you, so looking at the question,
Yeah, the original one.
you
Yeah.
have 20 in the first lot. Now you need to find a number such that 30 of them are less than. Right? So you've got 20 low earners in the first.
Right.
You've got 16 in the second, but you need only you need 10 of them, not all of them. Where does the 10 come from?
From the 16.
10. That's
Yeah, but why 10?
I don't know.
You're trying to get up to 30. You're looking for 30 low earners, 30 high earners.
Why are you looking for 30? Would you not be looking for 20 when it's from 20 to 60? Would that not be 40 altogether? And then,
Well, so down a second. So there's 60 people here. So we want to find an amount of money that 30 of them make less than, 30 of them make more than. So it's definitely 30. Yeah. So you've got 20 low earners in the first bracket. You need 10 out of the next bracket.
And why is multiply that by 10 then?
Because what you're doing, so I could, so my finger, if you don't quite follow this, you'd have to do the ogive, but I'll explain it here. So it would look something like this. Now this is X down here. So you're trying to find the amount of money such that 30 of them earn less than. Now you've got 20 in here.
Yeah.
We need 10 out of the next
Yeah, yeah.
lot. So we're assuming they're equally spread out. So that's difficult for me to draw even a bet. So what we want to capture is 20 here and 10 of
10 of
these.
those, yeah.
And well, if we're equally spread out, our answer should be 20. And the question is, what proportion of the distance will this be?
10 of those 16s, yeah. I
10 out of 16, so that's a proportion of the distance across. Like if you needed 8 of them,
10 then, yeah.
if you needed 8 of them, it would be half 8 out of 16. So the 10 represents the difference between these two. That's what's going on with that. So you're taking, answer is 20, plus you're taking 10 out of the 16, so that's a proportion of how far you're going to go. How far you're going to go out of this 10. So 10, this is, in other words, if these are equally spread out, this is 6.25. So I'd say.
If you're asked to draw a histogram then, GFO just coming up in the columns.
That's the easy one, yeah.
It's the
It's
same.
it's very easy. Yeah. Okay.
But either way, we'd actually be changing the original table to that format there, even if we're at for a histogram.
No, that's only if you're doing no guide.
What was it?
Yeah, otherwise the table you have is grand. Just before I get rid of the O-guide, I mentioned these, are any other questions? Oh yeah, there's another thing here, first and third quartiles. So the first and third quartiles is, so this is like the separate the small half from the big half. The Q1 is the small quarter. So this would be n over 4. So that's 1/15. Sorry, 15. So 60 of them, there's 60 of them. Q1 is the amount of money the lowest quarter make. And then Q3 is what the top quarter make. So you go up to 3n over 4. Go across. Go across.
B.
So this is a measure of the spread. So if this is very, very small, the middle 50% is all squashed together as such. So Q1 is this number here, which I'll call 19. Q3 is this number here, which I'll call 47. And the interquartile range is the difference between them.
Where did you get the 19 and the 47 then?
So the median is the middle half. Sorry, that's my sense. It's like the one that separates the small from the big. Q1 separates the small quarter from the rest, and Q3 separates the big quarter from the rest. So the quarter of the data is 15, so go across from 15, getting around 19. Across from 45, getting around 47. Obviously more accurate with graph paper. And then the interquartile range is the difference between them. So if you were to work with mean and standard deviation, so mean is like the average and the standard deviation is how spread out the data. If you were doing medians, you'd work median with interquartile range. So this is a measure of the average, this is a measure of how spread out the data is. And now we've got the assume mean method. So part C, it's talking about assume mean method. I would go straight to your formulas for this. So we've got two formulas. First one is Now, does it say about samples here or anything?
In the quarter rate, you have to get that from graph.
Yeah, you could do it the other way as well, but it's easy to do so. So I probably wouldn't, if I had the ogive, I'd probably ask for it. If I don't ask for the ogive, I probably won't ask for it. So it does say a sample, so we'll use the sample formulas. X bar. And we should use the sample standard deviation because the question says sample. C square root, add up, f by d squared, add up f minus 1, minus add up f, over add up f minus 1, times add up f by d, over add up f squared. So that's the stuff with the d's is the assumed mean method. Now the stuff it says there about class midpoints, that'll be gone. You don't have to do that anymore.
Why did you have the two formulas up there? Which one are you going to use?
Oh, because it says use the assumed mean method to determine the mean and the sample standard deviation.
What did you say was gone there just before that?
The determine the class midpoints. You won't have to do that. So you can draw this. From here I'm going to draw. I could go different ways. It doesn't really. I could either put the f's, the d's, and whatever this way. I could put them this way. It doesn't really matter. So let's see what we'll do. Maybe we'll put the d's. Or put all this stuff down here. So it doesn't really matter. Okay, let's look at what we need. A. Worry about that a little bit later. C. We'll worry about that a little later. Let's look at the f's. We need f. We're going to need d. We're going to need f by d. We're going to need f by d squared, so it might be easy to do d squared first, and then f by d squared, and that's, I think, everything we need. One, two, three, four, five, six, seven. So we get the table, we don't run it off, we get it from those formulas. So the f's are handy enough.
That formula we get them formulas.
That's on the sheet of formulas, yeah. So 20, 60, 5, 6, 5, 4, 4. Now we probably need the C and the A. Do we know what the C is? 10 is the width of the things. Now A, you can't actually get A wrong, but how do I say, the more your answer makes sense, the better. So you're going to pick one of the midpoints, either 15, 25, 35, 45, 55, 65, 75 to be the assumed mean. It has to be one of the midpoints though. What do you want to go for? 45.
30.
I'd suggest 35. It doesn't matter, but if you pick 15 and it should be way bigger, the numbers are going to be bigger. 45 is fine. I think 45 is a bit too in the middle as far as I'm concerned. You see, most of the data is smaller. I think 35
is... It's easier to pick the center one when you're doing up the table because you can just go 3 bins, minus 3 bins and plus 3 bins.
Yeah, you're right.
You know what I mean?
Yeah.
It doesn't matter. It's just
it doesn't matter. The numbers will be a little bigger. I think that makes sense, and actually we'll go with it. Now there could be 8 bins, so you have to make a choice.
Yeah.
Okay. Yeah, I think we'll go with that. That makes sense. Just showing it doesn't actually matter. So we'll go with 45. So that's the one with 6. So your assumed mean is basically in here. And that's 0 away. Now as the numbers get bigger, the D gets bigger, 1, 2, 3, and as you go backwards, the D gets smaller, -1, -2, -3. And once you've got that done, you're away with it. F by D.
Yeah, can you just go through that again?
So the D is the number of bins away you are from the one that you're assuming the mean is in. So this is the assumed mean, 45, and that would be, this one is nowhere away from the assumed mean.
Yeah.
And then the next one down is +1 away, +2 away, +3 away, and then go backwards. This one's -1, -2, -3. So what your colleague is saying is, if you just pick the middle one to be that, it's going to be 0 in the middle, count up, count up.
And this, you have 60 or 40, you just assume 45, and
Yeah.
between 40 and 50, and the original table, that's for 6 of it.
That's where the 6 is coming from.
If you watch the C,
The C is the width of the interval. So now this one is a bit confusing. 10.5 to 19.5. It won't be 10. It'll say 10 to 20. So say the 20 to 30. They're all the same width. So then you just fill it in. F by D -60, -32, -5, 0, 5, 8, 12. Then the squares, what will the square of this be? Plus, yeah, 9, 4, 1, 0, 4, 1, 9, 4, 9. And then F by D squared, so 20 by 9, 180. 16 by 4, 64. 5 by 1, F by D squared. 5 by 1, 5. Anything by 0 is 0. 5 by 1, 5. 4 by 4, 16. 4 by 9, 36.
Sorry, no, I know you said in a second with the 45. Why did you say that the 6 is relevant, or is it that you're on about the 6 point?
It's just, well, I mean, it's just this. It's just where if you look again at the original table, the 40 to 50
has 6 part or has 6.
6 from, yeah.
Right, but do we just pick that because there's 7 samples and we picked sample number 4 as such?
Yeah, just as the middle one.
That's all.
But like, I mean,
It's not because it's the number 6 that I was going to get.
no. You
It's
can
just-
pick.
it's
You can
just
pick.
sample 4.
Yeah, it's just you can pick. You can pick any.
Any of them, yeah.
It Any of doesn't
change final answer.
No, it doesn't change the answer one bit. The only thing is if you say if
Your D value will
I
change.
went back one,
Yeah.
this would be 80, and I'd have smaller numbers, but I get the same answer in the end. Yeah.
And just for the C, it'd be
Yeah.
like, looking back on the previous questions, what I did was I just added, it's the 10.5 and 19.5 and divided by 2. And then I get them as my x's, so I just got the average of all the x's, so it would be 25, 35, and the difference between the
No,
two
that
of
wouldn't
them.
be your C. Your C is the same.
The difference between the two of them is 10. Between them,
Yeah,
then it's
that's
10.
right. Yeah. It's the width of them. It'll be a bit, as I said, it'll be a bit clearer because you've got no 0.5s. It'll just be 10 to 20. It was just I finally won a battle against the day lecturer of that.
Why should we calculate these now?
Is that the next
F
form?
by D squared.
Well, why isn't that just FD square where you have...
No. It's not. It's F by D squared. If you want to do FD squared, you have to have a bracket around it because you do powers before multiplication.
Where did that 45 come for A?
So the 45, so he
Has
picks,
6 lines between 40 and 50, and that's between 40 and 50, is it? That way you get 40.
it's the midpoint 14. Whatever you picked A, you can pick whatever you want, but it has to be a midpoint. So the suggestion was, well, go to the middle one. So it make the D's very easy, 0, 1, 2, 3. And the midpoint of that one just happens to be it's between 40 and 50.
Yeah.
Okay. Do we have to add up F?
Yeah.
60. Yeah, it's up there. 60. Do we have to add up D?
No.
No. F by D?
Yeah.
Minus 72.
Do we have to add up D squared? No. I have to add up FD squared.
306.
This is great.
You trust them though?
I do. Trust them more than I trust myself and that, so I don't like the calculator. And now it's just bang, bang, bang into the formula. So x bar is 45 plus 10. Add up f by d is minus 72. Over add up f is 60. So it will be this bit will be negative if you overestimate, positive if you underestimate. And then s equal to c, which is 10 square root. Add up f by d squared is 306 over add up f minus 1. What do you think add up f minus 1 is?
59.
59, yeah. Minus add